Back to my channel. This is John from Cloud Tech Insight. Based on some of the requests from the users of SoAL, I'm creating a video to show how the SoAL can be deployed in AWS and as well as on Lambda. The blog will be going step-by-step instruction to follow the instructions to build an iceberg table AWS ecosystem. Just to bring this to your attention, the Spark on Lambda blog was published in 30th October, and one thing to highlight is the blog is kind of validated by the announcement by Databricks regarding their single node compute option. So people are finding it valuable to have a single node compute for their development activities. And if the workload is not that big, you can always run Spark locally. So as of December 13th, they released the single node option. So customers can leverage it for smaller workloads. So before we get into the demo, I want to talk about the high-level process. The very first step is to clone the SoAL repository, which is the GitHub link. I will provide the GitHub link in the description. And once you clone the GitHub link, you have to cd into the CloudFormation folder, and that's where all the SAM templates are available. Just for information, the whole process is automated using SAM template and code build. That's how you can achieve complete automated infrastructure setup. But if you think that, hey, I don't have access to these code build or SAM templates, I like to go the manual route, you have an option. Just like how I described in the local testing video, where you can build it locally, upload it to an ECR repository. From there, you can go to the console of AWS Lambda, create container or a Lambda based on a container. There are two options available. In this option, you will have to have access to code build, AWS SAM, and quite generous permissions, or you will have to come up with a specific permission for some of these activities. So the first step, clone the repository, log into the folder, execute the SAM template to build the image. So the image is building within the code build, and the code build will have the image locally. From there, the code build uploads the image into the repository. So just for your information, ECR repository is a repository where you hold your images in AWS ecosystem. From this, you can pull the image into Lambda, ECS, or batch, any of the container services. So your first step, always upload the image into ECR repository. Once the image is in the ECR repository, next step is create the SAM template, creates the SoAL on AWS Lambda. Just like how you log into AWS Lambda, create a Lambda from a container, the SoAL or the SAM template does these activities behind the scene on top of code build. So once this is done, you are set to go. You will have to provide the parameters that you need, where your script are, and update your code to ensure where you want to write on your S3 location, and ensure that always prefix it with S3A in the script. That's how Hadoop and Spark connects to the S3 folder. So once this is done, the Lambda is ready to go to execute your code. And like I said, you can always change the parameters within the Lambda to point the script to a different folder, or you can change the script itself, the PySpark script, to change the target location. So it's up to you. And at the same time, when you build this image, you can also specify whether you want a hoodie image, iceberg image, or the Delta Lake image. So based on your requirement, you can create an image, and then it can be created as a SoAL on AWS Lambda. And basically it's like EMR or Glue, where you can execute, the script can reside on an S3 location, and you can point it to S3 location. It can dynamically pull the script from the S3, execute it within Lambda, and provide you all the necessary logs. Okay, let's move on to the demo. Let's begin the session. So as you can read the blog from top to bottom, and this is where the setup is. And like I mentioned before, there are prerequisites mentioned here: access to CloudFormation, ECR, Lambda, and code build. And the very first step is cloning the repository. So I have opened Cloud9, where I can clone the repository locally. So it clones the repository and creates a folder called Spark on AWS Lambda. So it takes like a few seconds to clone the repository. And once it's cloned, and there will be a very specific folder called CloudFormation. Let me show you the folder structure. So you see this folder, you have the Spark scripts where the scripts are stored. The CloudFormation is another folder where all the SAM templates are source. So you have a CD into the CloudFormation folder. As you can see, a couple of SAM filter images and SAM template YAML. So these are the SAM templates that helps you create the image first, then creates a Lambda as and imports the image into the Lambda. So once you're here, go back to the blog, copy this template man here, and go back here, paste it right here. And one thing to keep in mind is the parameter, like the framework that we are providing. Here by default it's hoodie, but you can always go ahead and change here and say iceberg. It brings the iceberg image instead of hoodie image. So once this is done, it start its execution, and then once the execution is complete, you can see some of those image build and all those status is shown here. So once the image is built, we go back to the blog. But before going back to the blog, I want to show you the ECS part. You can see in the ECR part, you can see the Spark on Lambda image is being created here. So it's available as a private repository. And this is where next comes into this folder, pulls this image into AWS Lambda, and it builds the SoAL on AWS Lambda. So moving on to the next step is where you deploy based on these parameters. So one thing to keep in mind is there are a couple of things that you have to fill in some of these information. So these template, you will have to update some of the account number, the parameter value, where your script is stored. All these information have to be provided so that it can build the Lambda providing some of these parameters in there. So just to keep in mind, edit this line and then execute. So now the whole Lambda creation is complete. It pulled the image from the ECR repository, created a Lambda. So now I can go to the Lambda SoAL and see if it's created. There you go. We have it. We have this Lambda stack right here. Created Spark on Lambda is ready to go. You can look at the configurations, environment variable. You see the script bucket. You can go and edit if you want some of these information, and then you can hit execute to execute and create those tables in S3 location. Please let me know if you have any questions in any of these steps. Please leave a comment below so that I can add those information and make those updates accordingly. That's it for the demo. Thanks for watching the video. Let me know if you have any questions. I can create additional videos to make clarify things around Spark on Lambda. Like I said, please refer to the blog from Databricks. They have an option for single node as of December 23, and definitely it will help you reduce your Spark workload costs in general, as well as speed up your processes for some of your near real-time requirements. Thank you again. Please like and subscribe my channel, and you will be notified for the latest information from my channel. Thank you. Bye.